The presenters today from LT Automation will be Hector Rodriguez. Hector has been working for PREPA during 28 years. He is retired now. He joined LT Automation in 2019. He played various roles, including power plant chief engineer and others. But the most important one for the purpose of the webinar today is that he was the responsible person for the NOC team and OSI Soft Transpara Visual KPI administration during Hurricane Maria. From the Transpara side, Robert Hilton, he is the co-founder and parental supervision at Transpara, 25 years plus here in the software industry, and 10 years at Microsoft leading product management. And from AOP side, myself, Javier Sanchez, I am the Director General and founder of AOP, formerly head of OSI Soft Latam North from 2005 to 2011, lead distributor for Visual KPI and other products across Mexico and Central and South America.
Thanks, Javier. And let me start with a quick overview of what we're going to do today. So I'm going to start by giving you a quick overview of Visual KPI for those who have not seen it. I won't include the demo yet, but just a quick high-level overview about that and the company. Then we're going to spend the majority of our time speaking with Hector about his experience through Hurricane Maria and how they recovered and the various steps there. And I think you'll find it a fascinating discussion, as I have already. So let me dive in and make sure we have as much time as possible and time for questions at the end. And after we talk to Hector, then I'm going to show a little bit about our current crisis, the COVID-19 crisis, and a little bit about what you can do there and a few things we've done as well, including showing you some live software. So I'll dive right in here with a quick overview of what Visual KPI is. I like to start off just to set context about what's unique about this and what it's used for and why. So Visual KPI is a real-time operations system. It reads data from as many data sources as you have, whether those are time series databases or relational databases or data warehouses or IT applications or web services, things like weather or market pricing, security applications, manually entered data. It doesn't matter. And we read that data in near real time without moving it, which greatly reduces the amount of effort required to get a system running that looks across all your data and looks at it in real time and in context. So the first wave you see on the slide here is really the raw data. Where it gets more interesting is in the second step, where you decorate that data with things you know about it for the purposes of visualizing it, for the purposes of organizing it into a hierarchy or multiple hierarchies, and the ability to drill down or roll up performance automatically, for the purposes of analytics, and for the purposes of alerting on that data. And this can be everything from turning regular data like a temperature or a price or anything else into a KPI with color and status and meaning, but it can go a lot further into complete automation, items moving around, and we can even read this data or this metadata from external systems to fully automate Visual KPI. So the two things on the left here are really the ingredients for Visual KPI. And once you have them, you have a fully running Visual KPI system. And what I mean by that is you don't have to build all of the screens. You don't start with a blank canvas. Once you've defined a handful of KPIs or many, then you have a fully running system with most of our visualizations already running, a hierarchy you can drill down in and performance is already rolled up. And then you can take it further a few different ways. Drag and drop dashboards, of which you can have as many as you want, and they can be locked down or left open or secured away from certain users. Additional types of visualizations that are either ad hoc by the end user or managed by the administrator, or even embedded content from other systems put right into Visual KPI. You can also take it further through security itself. And then the last part, because we're dealing with data that is moving, notifications are critical, Basically, it's our belief that the software should be smart enough to tell users when to pay attention to it without forcing them to look around. So what this amounts to is if you think about the stock market app that might live on your phone, it has some characteristics about it that we just love. So it's painfully obvious. Even if it was sitting across the room from you, you can tell if you're having a good or a bad day or not, even if you can't read it. You could spend 10 seconds in it, or you could spend 2 hours in it. It's updated in near real time, but it basically gives you this constant sense of how are things going. Should I go get a coffee, or should I be paying attention because things are going haywire? So we try to apply that to people's businesses. But as you might expect, a business looks a lot different than just a stock market application, where the stock market application comes from one source of data and all the data looks kind of the same. It's not really what a business looks like. You may have lots of different types of data, lots of different data sources, different ways to connect to them, different speeds at which they update. So on the bottom of this slide, what we do is make sure all those systems look the same to our software without changing them in any way. That gives the users an experience where they can look at data as if it were all in one system. And then on the front end, we give that same concept as the stock market app, applying color and status and meaning and the ability to alert on as much as possible. So again, from across the room, you know if you're having a good day or a bad day, you know whether you need to drill it or not. So we're not just putting data on the screen for the sake of having data and forcing users to read it all. If we've done our job right, everything should become way more obvious, way faster, and combine all those systems into one. So that's a little bit of an overview of Visual KPI. This is a system that's being used in, I think, 27 or 28 different countries now. And we're not a new company nor a new piece of software. In fact, this is our 15th year as a company. And we do approximately 30 to 40 software releases every year. So there's a very mature product used in lots of heavy industrial uses and also in a lot of business uses. Let me move on real quick. That's the quick overview of us, and let's get to the real meat here of what we're talking about, and that is a conversation with Hector. So Hector, if you could turn your camera on and unmute, and thank you very much, first of all, for joining us, and thanks for having some conversations before this with me. I think it was very instructive, and even though you've said it a few times, it's a little tough to talk about. It's still a fascinating thing, and I think everybody who watches this will get quite a bit from it. So thank you for that.
Yeah, I appreciate it.
So let me start by just diving in here really quick, and let's get a quick overview of PREPA. Maybe you can give us a sense for how big it is and some things that are unique about it.
Yeah. Hi, good morning, good afternoon to all attendees. Thank you for being here. As I said, my name is Hector Rodriguez. I formerly worked with PREPA for 28 years, and at the time of the hurricane, I was the head of the Network Operations Center. A little bit about PREPA. PREPA is a vertically integrated company that has an installed capacity of over 5,000 megawatts, close to 6,000. It has about 2,500 miles of transmission lines, 230 kV, 115 kV, and 38 kV in about 48 transmission centers. And there are about close to 32,000 distribution miles of overhead lines in the distribution side. It has close to 300 substations all over the island. PREPA produces energy, distributes, transmits, does the billing, customer service, maintains its fleet. Everything's done within the same company by their own resources.
So that's a very unique power company in that respect, right? That it has
yes.
all of those pieces together.
Yes.
Okay, great.
It's a public company too, so it's covered me on.
Great, excellent. And then you retired from PREPA, and then you went to LT Automation, right?
Yes, I found that retirement to be a little bit slow for me. I always been in the line of fire all along my career, so I missed the action. So went back to work for a while now. still have a few years left in my brain to work with. And then started working with LT automation, working with many high-end solutions, Transpara being one of them, and mostly doing the analytics, trying to go into data and make sense out of it and present it to customers in a manner that actually they can consume and use as they need.
Great. And LT Automation was instrumental, if I understand it, in the Hurricane Maria story. They were working with you when you were at PREPA hand in hand. So we'll get to that in just a minute. But I think probably the best thing to start about here is a little bit about Hurricane Maria and maybe what happened before.
Yes, the Hurricane Maria period, and I'll talk about as a period because it's a big blur of events that happened, and it started basically 2 weeks prior to Maria. We had the pass of Hurricane Irma along the northeast part of the island. And although it didn't enter Puerto Rico, it grazed us very closely. Actually, it veered off at the last time. So we were ready to be hit by that hurricane. And even though the highest winds didn't pass, a lot of rain caused flooding, damages on the east side of the island mostly. And the electrical system survived, mostly on the west side. So the recovery started on the west side because we didn't go fully blackout. There were areas on the west that remained with power. And slowly we crawled back to the east, bringing the power back on to all the areas. So that happened like 14 days prior to Hurricane Maria. Actually, you could see on the radar, in the historical radar, Maria was coming along, forming itself right off the coast of Africa back then. So then enter Maria, and now we are on September 20th, and we got hit hard. I mean, it was horrible. Maria entered through the southeast coast near the town, the city of Yabucoa, and it crossed us diagonally from southeast to northwest. Actually, Hurricane Maria, the center itself, I just realized, I just did the measurement today, and it passed around 8 miles away from home, the center, from my home. And it was a tough experience.
That white dot, right? The white circle in there is about where you live, right?
Yes, that is correct. So I didn't realize how close it was. I knew it was close. I just measured it to make sure I understand how bad, because we were basically in the eye wall all the time. The center didn't pass over my home, but the eye wall, we were on it most of the time that the hurricane passed. So it was a very traumatic experience. Thankfully, my home and my people survived. But the house, at some point, doors were trying to pop open. You could hear the howling, the high pitch, the low growling of the wind moving around, and it was a nightmare. Rain seeped in, water seeped in from crevices you didn't even know your house had. And it was a constant fight just to keep it dry inside. So it was a very active and tense moments while this passed.
So you weren't in hiding. You were working the entire time. It was trying to keep it at bay, right?
Yeah, keeping you busy keeps your mind off the bigger worries. So you go into soldier mode and keep the mission going, I guess.
Great. Okay, so anything else about just your personal experience there before we sort of transition to what happens with your role and with PREPA and work?
Yeah, I mean, all the time this is happening. The power went off very quickly. Right when it was entering, we lost power because the hurricane entered the east coast, the southeast coast there, and there's a big 230 kV line moving through that area. So the power plants started dropping out because they had nowhere to put the power to. So we went into blackout. Actually, we lost the radar, the dollar radar that is on Cayenne on that area. It was one of the first things that went off. So we're blind. We just know what's happening. So at this time, it's about praying and staying safe.
And if I understand it, the most of the power generation is on the south side of the island, but most of the population is on the north side. And so you've got this crossed right between all that and took pretty much every possible way for power to get, not to mention that the power generation shut down anyways, but really wiped everything out.
Yes, it did. It was like a saw cutting the island in half.
Right. Okay, great. And a very mountainous island, not just a city or something where everything's easy to get to.
Yes, the center of the island is mountainous, so there are valleys on the north and south coast, but the peaks on the highest mountains are right across the east to west geometry of the island. So it left a lot of rain. It dumped in places like 38 inches of rain, and flooding got horrible. At some point, mudslides were terrible, especially on the central west area. It's a different kind of terrain, so there were mudslides taking away homes, poles, transmission lines. There's a statistic from NOAA that about 80% of power poles just went down. So there was nowhere to
80%.
80% of the poles were down. So, and
Wow.
most of the transmission lines, the big towers were down too. So
Yeah, and I think we have some pictures of that coming up. So, and speaking of pictures, and maybe transitioning now from, the hurricane passes, or maybe it's even still remnants of it there, you tell me, but it's now you have to come up for air and say, what's my job? And how does this, it's time to figure out what's next. What is next? What goes through your mind at that point?
well, as I said, I have always been in the line of fire. This was not my first rodeo. I worked through Hurricane George, Tropical Storm Jean, many other hurricanes that passed over the island. So nobody has to tell you. You just gotta go back to work. I mean, there were no phone lines, there were no communications, there was no internet, no radio stations. Only one radio station survived, and TV stations. The hurricane took down their transmission towers, so there was no transmissions. So people in the U.S. probably saw a lot more than we actually did during the hurricane due to other media that was available to them.
And so when you even go to leave your house, you don't actually know what even exists out there. You don't know
No, you
if
you don't know even if you have a pass. I mean, you
yep.
don't know if you could drive your car to work. You don't know how much flooding there was. And actually, that picture is actually the next morning, me leaving my house trying to get to work. That's I leave my home, turn left. That's what I see. So once you start seeing that kind of stuff, you know you're in for a ride. And I live about maybe 10 to 12 miles away from work. It took me close to an hour and a half just to get there. You had to avoid every piece of debris on the road, every cable, every wire, towers, poles, you name it. All sort of stuff was on the ground that day. It was like a bomb went off all over the island. So
Yeah, let's look at a few other pictures here. I think on the left here, you said this is a solar farm that got pretty much destroyed.
yes, it was around a 40 megawatt solar farm located on the southeast of the island. It was relatively new back then. It was starting to ramp up in power. And as you could see, it took off a lot of their solar panels. The other images you see, that was the norm all across the islands. Roads blocked with power poles going down, wires, towers bent in awkward ways. I mean, it's like a kid just bent them just for fun. It was horrible.
Yeah,
Uh,
you can see some of them here, and you can see just how big that storm is from
yes,
that image.
yes, and those are transmission towers that just their support cables were down, and once that happens, they buckle and under the tensions of the wires. If you ever play golf under a transmission line, you could hear the whipping of the cables. It's a
Yeah,
weird noise, and that's a normal 10 to 12 mile wind. Now imagine 150-mile-hour wind blowing over, then what happens to those lines? So the towers just went down. There was no help in that.
And Hector, if I understand it, a lot of these towers are not someplace you can even really get to, correct? These are in the mountains. There's really no easy way to even access them.
Yes, remember that 70% of the production of energy, it's on the south side, but 70% of the population is on the north side. So you depend on those transmission lines crossing over from south to north and around the coast of east side and the west side to bring that power up to the island. So if you cut those, there's no helping it. We're going blackout.
Right, and not just blackout for a little while. Tell us a little bit about how long power was out. Maybe completely, and then how long this actually took, and then we'll get into the more details about what you did.
Yeah, we're talking about weeks. Power started going back up a week, 2 weeks after that, because PREPA has all around the islands many startup gas turbines that can start and produce power initially locally. And then as transmission lines start going up, start moving that power and crawl all over the island. So that's one key process to keep in mind. But the recovery was very, very, very slow. The poles were down, the transmission lines are down, and you don't put back up those in a moment. Along with the transmission lines, down went the communications. I mean, all the fiber optic cabling and all the communications for PREPA to control the substations and everything run on those poles as well. So now they're down. So it's a horrible issue there.
So that's a good segue here. So on the lower left here of this slide, we have a little bit of kind of the order in which you start to think. Is that right? Maybe walk us through that a little bit, and then a few of these photos.
Yeah. Once we were able to reach the headquarters, we started to think about how we're going to go about this. I mean, all procedures are out the window. You need to not improvise, but do work in a very, very careful manner because your life is at stake. Many of your co-workers' life is at stake. So every step you take must be thought through and carefully planned to make sure everybody's safety. So safety was a foremost parameter then. You had to bring up the transmission lines, once they were up, the wiring comes up, you started putting back up the communication infrastructure, and then they get the power back up and start powering things up. There were emergency generators all over the place, so locations had those kind of communications. And one key detail here is that PREPA runs on OSI soft platform. So all the operational data is stored in OSI soft. And while the hurricane was approaching, we decided to allow OSI soft die with its boots on. I mean, it went up to last gasp.
So run to failure, not shut it down automatically and not gracefully, but just let it run, and like the equivalent of pulling the cord out of the wall eventually.
Yes, the decision was made because we knew that that kind of data would be more important to diagnose malfunctions that we knew we're going to have eventually, because we had the experience before that even though databases get corrupt and files get corrupted and it's a nightmare to bring it back up, it can be done. It just takes a lot of effort. So we put more value on the data that we were going to store on the last gasp than on the recovery effort. We knew we were going to take a lot of time to recover anyways. So we had time for that. So that was the decision. But once you get up the power to the data centers, then you bring up the servers, repair the databases, and then restore the communications to the central command. So in the process of bringing up power to the data centers. There's a story, that picture on the top left is we were trying to reach a coworker that knew all about one of our recovery centers, power to power that data center. And we went actually searching for him. We didn't know if we could find him. We just drove on the right where the hurricane came in, and tried to ask for him all over the town until we found his home and we find him safe. He was actually working, trying to bring water back to his community back then, because there was no way of reporting or going out where he was. So that was and the paper I'm holding is actually the procedure that we put up on the fly to power the data center back up.
So he had to handwrite, here's what you have to do, and you had to just basically hunt for him and knock on doors till you found him.
Basically, yes. And then we do that procedure and drove back to the power plant just to power back things up in that respect. So now there's power, now there is data, there are some limited communications. Now there's, we repaired the databases, OSI's Office backup. Now the other applications that feed off OSI's of Pi are starting to pop numbers and change colors to say the status of things. Now the tough part comes about how to interpret and make sense of the data that we captured during the event. And we had to scratch our heads, starting to look at stuff and try to figure out a plan to put everything back in service. So that was the take action part.
And so just to summarize this, you first have to safely get in and see what still exists. You have to get enough power and communication to run your own systems. And this isn't yet recovering the rest of the island. This is just recovering your ability to even see and access data and be able to work. And then once you do that, now let's interpret what we have, what happened, and what's going to go next. And so this is the part where you start to look and start to use Visual KPI again, right?
Yes. Now, remember that the primary source of data is OSIsoft. So we had Visual KPI. It was in implementation since around 2014. We were developing dashboards, and one of the first models that we actually did was the distribution side of the network. So we had a model with normal values, normal highs, lows, and parameters that we had on data from that period. The problem now is that data is off the window. It's a new model. Now the substations were being wired in different ways in terms of loadings. It was not what was the optimal route. It was how can you get to the customer to give him power. So some feeders were higher than others in load, lower than others in load. So now everything showed low or others extremely high in Transpara in that way. So, but we did have the settings, and we knew by using Transpara what the targets were. So now we were trying to figure out how we adapted to measure the progress of the information that we have right now. So in that respect, LT Automation back then helped us a lot. They were sitting with us hand in hand, working with these issues. So we started gathering that new data and new analyses and parameters, and reprogrammed the Transpara to show the actual values that were happening at the moment. So that gave us an idea of how we were doing with the new normal back then, to give us a target. And by using that, we started figuring out how was the progress of the re-energization of the island. And we use that information to pass it along to the appropriate channels to people to make their decisions on where to go, how to energize. Can they do more? They have to hold and do other feeder. That information started helping them in their decision making.
And tell me, you said the statistics were quite important. Maybe talk a second about that.
Yeah, the statistics in terms of we started analyzing what we were doing. One of the good part of Transpara is that you whatever you put on screen, you can analyze with the click of a button. You press the information, and it will give you highest, lowest, average, trending. It will give you all the information you need to reconfigure the Transpara by itself, and then start let's because it doesn't make much sense to have a feeder that is showing triple high in current or triple low. It just says nothing. So it is more important the change over time than the actual value. So you need to start reconfiguring stuff to measure how you went along. So that is an important part of how easy it was to reconfigure Transpara along the way. Actually, we did it in my office in moments notice, just a couple of hours, just to do the analysis. And keep in mind that let's be fair here. We were working with the Transpara that we have in 2017, not the Transpara that we have today. And many changes have improved along the years, and we were making the most of from the limited resources that we had back then. Not necessarily transferable, all the information that we were able to get.
That's great. And then you said not only the ability to make changes quickly, but if I remember right from one of our previous conversations, a lot of this was about saying what was normal and how far off are we from normal every day as we
Yes.
recover. Is that kind of one of the main things you're measuring along the way on each metric, is how far away are we?
Yes. As new customers were added to the grid, loads on the feeders starting going up and up and up and up, and we were approaching the normal values. So at some point, then whatever values you set for normal, high, low had to be re-engineered again. So we got to go back and look at them and reprogram the Transpara to make sure we were actually on target. And by doing that, measuring the currents, and we knew it was not by any chance precise, but there were not many other options that we had. We started measuring the currents, looking at the bus voltages. It's three-phasic. We only we only had data from one phase, trying to figure out, say, if a substation is producing, it's supplying 10 megawatts of energy to the customers, and the data from 2017 prior to a hurricane said that that substation had been producing like, not producing, just distributing up to 20 megawatts of load, then we knew we were at what percentage away from being normal. So that started coagulating. We started passing that information along, and then the decision makers started getting grasp of how far we were along the way. But it was months before everything went back to normal.
And even getting to normal, if I understand it, wasn't a smooth process, because you would energize and add, and then there'd be another blackout. There was other things along the way. It never kind of wasn't some gradual, smooth process, right?
Yeah, we had a few blackouts right after Maria. I remember that you try to energize, and you do this kind of quickly, and there were not many parts around to repair everything. So if the part looked good and isolator looked good, well, just let it go and move on. And turns out when you start loading the lines, they stretch a little bit, they heat a little bit, put some more stresses on some part. That part might break. So the line went down and we went blackout. So it was very unstable for a few months after that. But we were trying to do our best to bring energy to the customers. It was a constant fight.
I can only imagine. So, so here's a couple of other images. Anything interesting to say about these?
Yeah, that on the left is actually a substation. We have, as you mentioned on the first slides, data is data, but without context and other information to correlate, it's just a number. I mean, you need to put that feel of what's going on with the data. Actually, you said it perfectly. Do I relax or do I panic? That's a very good way to put it. So on the top right, you see a region of Puerto Rico. That's the southwest corner of Puerto Rico. If you haven't been here, there are very nice beaches in that area there. But looking at it, you could clearly see there are a couple of red areas there. Those are feeders that are overloaded. So if you click in one of those bubbles, you could actually go down to the substation that is mapped in GPS. So you can actually see it in Google Maps and figure out which feeder is giving you trouble in high load and how it has been trending. But if you want to go into further detail, you just touch on the red banner that is on the left there, and then you go into the detailed graphic, and you can figure out why is it in an alarm state. And from there, you can analyze that information and figure out either if the substation, the feeder might be overloaded, which can happen. The parameters for the alarms can be misconfigured because it evolved and changed over the time. And we found up to earlier this year, we went back into the Transpara and checked all the configurations. And we found that we were very, very, very close to the parameters prior to the hurricanes Irma and Maria. And since we had those settings, then we were able to load them back up and then filter by the ones that were off target and adjust the targets on those minorities. But we're talking about 1,300 feeders all over the island. So if you got to go one by one, well, you can do it. It will take you a lot of time, but you can do mass uploads and everything.
And I think that highlights one of the things that's a little bit unique here with this approach, which is instead of saying, here's all my data, now go look at it and go find out and be a subject matter expert who has to go read it and find out if things are going wrong or not. You kind of flip that on your head and say, let the software tell me when something needs my attention, and only the things that need my attention will I drill into. And so letting the software do a lot more of the work there for you. And then once you do get down into the details, like this trend, you can see how long has it been in this state? Is it getting worse or is it getting better? Is it erratic or is it consistent? You know, all these other things, but you only do that once the software has told you, hey, this one probably should be looked at, rather than waiting for a human to go look at all of your assets or keep all this information on the screen at all times.
Yes.
Great. And then, I mean, feel free to add more, but also we can transition now to, you know, you've recovered, you've kind of got things back to where they are. What's now happening and what's planned going forward?
All right, so Transpara is still going strong. We are adding more information and preparing it to deploy it more granularly down to the supervisor and engineers in the distribution side of the operations. But there is also a use in the transmission area. There is a very good use for it at the power plant level. Say for in this image that we are showing here, it's showing the tank levels at the power plant for fuel. So now you got a coordinated effort. You know how your assets are along the way, and it's so easy to do and see over your phone that you can get it on the fly. You don't have to be sitting down at your computer stuck there just to get insights of information. So I always say to my colleagues and customers, you turn up your phone, you open Transpara, everything green, go back to sleep. You see a piece of red, you better have your coffee in a hurry. The idea is to put the intelligence once. You get your subject matter expert to do the intelligence for you. You can configure it in so many ways that it does the initial analysis for you. So that cumbersome thing about sitting in your computer, open out 2-3 applications just to do the thinking, bring it into Excel, do a conditional formatting, and that is all done for you in Transpara. So it's easier on your life.
And one other thing that we hear from a lot of people is this difference between reports versus this sort of real-time or near real-time kind of view. So, and not because it's faster, but more because everybody's looking at the same thing at all times. So especially in a crisis or after a crisis or any kind of situation, no one's looking at data that's, oh, I happen to be looking at yesterday's report instead of today's, or last week's instead of this week's, or anything like that. How important is that in this scenario too?
Yeah, it's very important because you can actually notice something on a view that you have. You can actually just email the link right on the fly to the person that you actually trying to communicate, and instead to trying to describe over the phone a problem, you both will be looking at the same data, and the solutions come about quicker. So it speeds up the integration in between departments, and the communications and solutions move faster. So we have been talking only about electrical sides, tank levels, but you can apply it to just about everything: vibrations, any sort of machinery status, environmental, anywhere you mention it, it goes into Transpara and it makes sense out of it. So
Yeah, I
it's a
think
very important tool.
we even recently just talked about possibly adding weather and other things into the solution, as that may have an impact as well. So other even external data sources. Great. And then probably more automation, I think, on your side as well. You guys are going further with AF from OSI Soft, which we have a native integration with, which will sort of automate the configuration of Visual KPI as well.
Yes, since there are many repetitive assets, such as the feeders, the substations, weather stations, and many other assets that are repetitive, AF is a great platform to put that in. And Transpara, we just connect to them very easily. So we're working in that respect as well to get it going.
Excellent. So, I think that's a extremely useful and dramatic, if I might say, situation you guys lived through down there. And maybe we can either pause for some questions, or I think maybe given the time, we'll hold that until the end. But maybe you can talk just about this one last photo, and then I'll switch over and show a few things.
Oh, well, it's so hard to take down a Puerto Rican when he wants to have fun. I mean, that is Christmas in Puerto Rico after Maria, and those pictures, there are many of those around, but that's a funny one. I mean, the pole is down on your home. There's barely enough power to light a candle, but you got to put your lights on, and your Christmas mode is on. Everybody was ready to party there, so we're gonna have fun anyways. So.
That's right. And I noticed you called out on one of my earlier conversations that even the meter is still on that one.
Oh, yeah.
So depending on whether they're going from a generator or if they actually have power here, but if they have it, they're getting metered, right?
Yeah.
Excellent. Well, Hector, feel free to add anything else, but thank you very much for this. It's a very interesting story, and we're so happy that everybody has recovered, and hopefully, I hope it doesn't happen again, even though we know various things will. But it's good that you're more and more prepared as every day goes by.
Thank you.
So thanks for that, and we'll come back at the end if there's any questions. But for now, I'm going to switch over and talk for a few minutes just about our current crisis that actually doesn't hit any particular geography, but really hits everybody and everyone's business to a certain extent. There's plenty of businesses who have been demolished by this crisis. There's others who have been improved by it. But it's still an ongoing crisis. And so I thought I'd take a few moments to show not only what we've done and what you can use outside of your business to kind of monitor this, but you can also apply some of those crisis management or crisis recovery approaches that Hector mentioned in your own business outside of it. So I'm going to share my screen for a minute, and let's walk through the COVID-19 site that we created here. And I'll start by saying that this is free, this is public, you're welcome to use it. The link you should go to is transpara.com/COVID-19, which you can see on my screen here. There's a video here, which if I have time, I'll show you later. And then there's a little tutorial here as well. But if you want to skip right to the live data, there's buttons all over this page that take you right to it, which will take you to something that looks like this. So you've probably seen lots of other tracking sites where you're able to see various pieces of data, and you'll see a few things that are a little bit unique about ours. And along the way, I'll show you kind of the main things that happen with Visual KPI, or some of the big themes about it if you're new to the software. So first of all, for the end users, the software runs in a browser. So you can see here, I've got Google Chrome here, but it doesn't matter. And I happen to be running Windows, but it doesn't matter. Our software is used in everything from embedded inside of machines to big screens on the wall. In fact, Hector showed me in one of their control rooms, I think they have an 84-inch screen with Visual KPI on it as well. So you've got a lot of different ways to do it. And also it's a fully responsive mobile web application. And what that means is that the page on the left here and the page on the right are actually the same page. So as I shrink my browser down, you'll see it figures out what it needs to look like at any particular screen size, and then you're kind of ready to go. So you don't need to do any special configuration for it to work on phones, and every feature works on every device. And lastly, it's updated in near real time. Now the data here in the COVID site is stuff that updates mostly once a day. So it's pretty slow moving by our standards, but still quite interesting. I have a few other sites here open. Here's a power generation one. Here's a transmission and distribution one, etc., which are all a lot more high frequency data and other things, and even mixtures of many data sources. So back to the COVID site here. Now there's three main ways that users interact with our software. One of those you're looking at here, and that's the dashboard. And in this case, there's many dashboards in this system. So there's profiles here. I have my own personal profile. We've got other geography-based profiles and dashboards in here that we've made already, and you're welcome to go make your own. So you can see I can toggle over to mine where I'm looking at a particular set of states and how they compare in cases and deaths. And these are all normalized as per capita. This is very helpful. This is some of the things that you won't see in some other trackers, which really lets you compare a giant thing like the country of India with the country of Brazil with a county in the US or any other size geography. You can compare them with each other in a normalized way. So down here as well, I've got some states and then I've got some countries compared to each other. And each one of these you can see is quite instructive here. You can see here this is the, let's see, total cases per capita. You can see just how bad the US is compared to some other countries. You can see Australia down there at the bottom. And just close to the bottom, you can actually see the global cases as well. So you can see a lot of these countries are doing much, much worse than the global number. So that's an example of another dashboard here. I'll go back to let's go to the US really quick. And in here, I've got some state level dashboards. I've got a few other comparison ones, but again, you can go make your own. So I'll come back to the dashboard in a minute. So that's one way people use the software, the dashboards. The second is the hierarchy, and this is equally important to a dashboard. And I'll show you this on a few different sites here. Here's on this PowerGen site. Here I'm looking at the roll-up, and these are automatically generated visualizations. The roll-up of these regions, and I can drill down into a region, then into a site, and see those KPIs and see how they're performing, etc. If I look at the transmission site here, you'll see a different type of hierarchy where I'm looking at it by the type of equipment it is in most cases here. And you can even have multiple hierarchies in here. So let me go back to COVID because it's a little bit unique. This one has what is our custom rollups feature, where instead of just a percentage of the amount of KPIs that are in good or bad states or various levels, in our case, we're showing just cases and deaths, cumulative, and stack ranked. So as I drill into something, like I'll go into North America here, And at each level, I have other KPIs and charts and other things. So they're sitting down here, I can see them. But as I keep drilling in, so I'll drill into the US here, and you can really see the differences in all these pieces here. You know, this is stack ranking the worst states. Now, I happen to be in a big state here in California, but also one that is having quite a few challenges. And especially all those challenges you can see here quite quickly are all around Southern California, where I'm here based in San Francisco. If I go down here and look at that, you'll see our KPIs. So I'm now at the bottom of the hierarchy. You can see I just drilled in here all the way to San Francisco County. And then I can switch over and look at some of these charts, like let's compare the cases, 7-day average, with San Francisco County and all of its parents. So you can see the yellow line is San Francisco. And then the light blue line, the lightest blue, is California. The next is the US up there at the top is the worst. So we're doing, you know, California is doing better than the US. North America is doing better than California. San Francisco County is doing a lot better than all of them, but we're all doing a lot worse than the global average. So that just shows you again just how poorly the US has been in terms of controlling the virus. But that's a quick way to use the hierarchy and get that context. And again, at any level, if I go up to California, for example, and I switch over to charts, I have that exact same chart in here of 7-day average of cases compared to the parents. So in this case, I'm just going to compare California to the US, to North America, to the global average. So that's a way you can just navigate, find your own geographies, compare them. And then we have this feature called the watch list up here. So if I get to a particular KPI and I want to look at California, let's say new cases daily, I could just say here, new cases daily, or let me go actually to it. And I can say, I can add this to my watch list. And as soon as I do, then I can go find another geography, even one that's completely unrelated. And then once I go to my watch list, I can go pick those and make a new trend. So I'll show you that here. If I go over to my own profile, you can see I have a bunch of things on my watch list here that I've added myself as an end user. And then I can go up to these and just say, you know, I want to pick a few of these. Let's do cases and deaths. Let's do Arizona cases and deaths. And let's do California cases and deaths. And then I can simply go in and trend them against each other. I could switch them over and stack rank them. Obviously, the cases are higher than the deaths. I could even make a pie chart out of them, all these things, but nobody has to go build any of these visualizations. Once you have data configured, once you have KPIs that exist, it's just a simple matter of choosing which visualization you like. And then if you like a particular one, let's go back to this one here for whatever reason. And then you can simply go up here and say, I want that on my dashboard. Let's go configure my dashboard. And that new object is sitting right up there at the top. I'll just put it in an interesting place here, save that. And now you can see my new chart is added to my dashboard there. So you're not developing visualizations, you're not out configuring, doing heavy load things. Your end users can make up their own visualizations once there are KPIs, once there's a hierarchy, and once there's any other visualizations that you care about. So that's a quick way to drill down through the hierarchy there. The third main way that users interact with our software is the concept of search. And it doesn't matter where you are in the system. So I'll switch to this demo really quick. And if I start typing in the search box, and this works on your phone, as does every other feature, I'm not only going to get live search results, but I'm going to get the live status of what I'm searching on. So in this case, I've got 19 KPIs that meet this search requirement. I'm showing the top 5. And if this San Leandro KPI was what I was looking for, then it's going well. Maybe that's all I needed to know. Or if I did want to check in further, I can click on it and drill in. I also could make a group of KPIs myself by clicking on this banner here, this header, and now I've got all 19 of those KPIs. And I could switch the visualization, I could run analytics on it, I could map those, I could look at how they're doing over time, I could change the time range, I could add this to my dashboard, even group them by attribute. which is a very important feature, this ability to have custom attributes in here. So where Hector mentioned that they have, maybe feeders and they have substations and they have all these other classes of equipment, they might also have geographic regions, they might have brands of equipment, they might have types of generation, they might have all kinds of different attributes, and they can take any set of KPIs in here and just pivot it by those without ever building a pivot table, without ever doing the work of OLAP cubes or any of these other very heavy lifting kind of things. It's really just decorating your data with things you know about it and then letting your end users interact with it in any way they choose. So that's a little bit of an overview of some of the key functions that you might interact with in Visual KPI. Now, the last thing here is how you might go about making your own site or your own dashboard. So if you've come over to the COVID-19 site here, you can simply go over here and say change profile and make a new one. And we can call this our crisis webinar profile, and I'll save that. Now I have a blank dashboard here and I could simply go over and start finding things. Let's say this is an interesting visualization that I want on my dashboard. So I can go over here and add that to my dashboard. Then maybe I care about the US, and let's look at some KPIs here, and let's just pick a handful of these and say I would like to know my total cases and my total deaths and my new cases and new deaths, and let's add those to my dashboard here. And now you can see if I go to that green box, I've got all of those objects. I can simply just put them where I want and whatever size I want. And save that, and I've already started to build out my dashboard. And so I can go get any other visualizations, make that yourself. And again, if you want to compare things that aren't in the same group in the hierarchy, you can just use that watch list by adding objects to it and then going over to it and multi-selecting them and adding them to your dashboard. So that's a quick overview of that. And I think we're about out of time here. And I think the team has been monitoring the chat here and we don't have any current questions next. But let's get a little bit of, or one last thing I want to show you here is a video about the COVID-19 thing, and then I will pass it over, or we can say thanks and give you some contact information. So let me just run that video now and have a listen.
COVID-19 is causing a lot of confusion. With all of these mixed messages and political bias, how do you uncover what's really happening? How do you make informed decisions that affect your business, your family, and your health? Data is critical, but numbers without patterns are useless. If presented correctly, those patterns emerge and become obvious. At Transpara.com/COVID-19, we created a free, real-time site to help you cut through the noise and get right to the facts. Create interactive and personalized dashboards to help you better understand the current status of any geography. Compare data by continent, country, state, or province, and county, including per capita information, so you can compare any size geography with any other. Look at testing and hospitalization data, growth rates, and more. New metrics and sources of data are being added regularly. Use the predefined dashboards and visualizations, or make your own. Look at 7-day averages to monitor the recovery or see how your area compares with any other or the entire world. Data should be free, especially during a crisis. Facts don't have opinions, and educated decisions are better decisions. Visit Transpara.com/COVID-19 to learn more and access the live data.
Okay, so let me just jump back and maybe Hector and Javier come on back here. And we will see if we can. Yeah, and so first of all, again, I wanted to thank Javier and Hector for your time and for helping prepare, and Hector for gathering all this information and unfortunately reliving it a little bit. I know that's no fun in times like this, but maybe to wrap up, we did get a couple of comments in the chat window about some really dramatic images and people finding it quite fascinating. So thank you for that. And then maybe wrapping up, Hector, where can people find you, or LT Automation? Where do we track you down if we need something?
All right, you can search for me in LT Automation, www.ltapr.com. And I just posted on the website, on the chat, the link for our LinkedIn place. So make sure you follow us. Stay up to date with Transpara and many other solutions that we provide.
Great. And Javier, how about you?
Well, my email is arturojavier.sanchez@aaop.mx or javier.sanchez@transpara.com.
Excellent.
Thank you.
Thank you for the opportunity.
Yeah. Thanks, everybody.